Welcome back. My name is Mwiza Chirwa. I'll be your presenter in this video. So today we'll start looking at chemistry book 4. The first topic that we're going to start looking at is rate of chemical reaction. So let us be together and learn more about this topic. So before we start looking in details on what we're going to learn or what we're going to expect, first of all, let us look at the success criteria that we are supposed to achieve. So by the end of this lesson, the following success criteria are supposed to be achieved. First of all, we're supposed to be able to describe factors that affect rate of chemical reaction. So this is the main objective that we are supposed to cover for a short period of time. But to be precise on what we're going to do in this lesson, based on the main objective, we're supposed to define the term rate of reaction. We're supposed to state factors that affect the rate of reaction and discuss how surface area affect rate of chemical reaction. Now, since as we have looked at the success criteria that we're supposed to achieve, now let us look in details what are we going to learn much on this topic. It's so interesting, and it still needs us to have a preamble on chemical reaction from Form 2, as well as the stoichiometry from Form 3. This background will help us through to understand some of the concepts that we are going to learn on this topic. Now let us start. So we are going to start by looking at the topic itself. We said it is rate of chemical reaction. Now we'll be describing the words in the sentence known as rate of chemical reaction. So we'll start by looking at the word, the term chemical reaction. So in the term chemical reaction, we need to define the term chemical reaction. So several scholars have tried to define it in different way, but we from here I have simplified it in this way. We'll define it, and the later one should be able to know what happens. So when we say chemical reaction, it is a process where substances called reactants and undergoes a transformation to form new substance known as product. It's a process where substances called reactants undergo transformation to form new products. So when we are talking about transformation, this involves the breaking of the bonds from the reactants and the rearrangement of bonds and forming new bonds which are formed in the product. So it can also be defined in simple terms. It can be defined as a process which involves bonds, breaking of the bonds in the reactants and formation of new bonds in the product. All these ones mean what happens during chemical reaction. So during chemical reaction, the atoms in the reactants are rearranged to form the product. The atoms of the reactants, they are going to be rearranged to form new products. No atom is going to be destroyed here. What happens is that the bonds are broken. As the bonds are broken, they are going to be rearranged to form new bonds, which are the products. Different chemical reactions get completed at a different time. Not all of them can get completed, or it can occur in the same period of time. So during any chemical reaction, the reactants are used up. As the reactants are used up, this leads to the decrease in the mass of the reactants. So what will happen if the reactants are being used up and the mass is decreasing? The products are going to be formed and the mass of the product is going to be increasing. During chemical reaction, the particles of the reactants collide. For a chemical reaction to occur, it means the particles of the reactants must collide and react to form a product. For the reaction to collide, for the reactants to collide, it means they need to have enough energy. Otherwise, they cannot collide. For example, if we may take a solid disk and put it somewhere else and take another solid disk. These ones do not have enough energy and they cannot react since they are also in solid state. There will be no any reaction. So for us to understand chemical reaction, or for the reactants to collide to have a reaction, they must have enough energy. They must possess energy in them. So if they collide, if the collisions are successful or fruitful, it may lead to a reaction to occur. But if the collisions between the reactants is not successful, the reaction may not take place. So now we look at rate of chemical reaction as a term. So what is rate of reaction? Remember, we defined chemical reaction. Now we're supposed to define rate of reaction. So different, we have many definitions. So it can be of your preference to choose which one is simple to use. So when we talk about rate of chemical reaction, can be defined as follows. Is a measure of how fast or slow reactants are used up or how fast the product are being produced. It can also be defined in this way. It is the proportion of the decrease in concentration of the reactants and to the increase of concentration of the product. Now, before we go to another definition, let me try and explain this definition properly. So if you are using, for example, you are reacting liquids, liquids have different concentration. So the definition is saying that it's the proportion to the decrease of the concentration of the reactants. Since the reactants are being used up, we expect that their concentration is to decrease, while as the product are being formed, that new product, the concentration is supposed to be increasing since it's being formed. So it's being converted from the reactants to the product. Therefore, the concentration of the reactants must decrease because it is being used up, while the concentration of the product must always increase because it is being produced. We can also define it in this way. It is a change in the amount of the reactants or products per unit time. It is the change of the amount of the reactants of the products, the change of the amount of the reactants or the products per unit time. Now, since we have said that not all chemical reaction can take place at the same precise time or has different time to get completed, we can calculate rate of chemical reaction. Why are we learning of calculating the rate of chemical reaction? Remember, the topic stipulates that the concept which are going to be learned here, it is not only going to be applied academically, but it can also be applied in industry. For example, if you know the rate of chemical reaction, you'll be able to know the amount of products that can be produced by a specific time. And you can be able to know which part you're supposed to add more to produce more products per time because based on the time frame given as well as based on the supply. So it is very important to calculate rate of chemical reaction, most especially in industry where goods are going to be produced. So there are several formulas that we can use to calculate rate of reaction depending on what we have been given. So you can calculate rate of reaction by using this formula, amount of reactant used up divided by time taken. Amount of reactant used up divided by time taken. So in chemistry, when we are looking at amount of reactant, in simple, we are looking at the number of moles. We are looking at the number of moles. So if we are given the number of moles of the reactant, we'll be able to calculate rate of reaction. We can also be given the amount of product. It means the number of moles of product. We can also calculate the rate of chemical reaction. So another formula is that amount of product formed divided by time taken. We can also calculate rate of chemical reaction by using concentration. So change in concentration divided by time taken. So when we are talking about change in concentration, it means we have concentration of the reactant as well as the concentration of product. If we subtract, we're going to find the change in concentration. That change we can divide by time taken. We can find the rate of chemical reaction. So overall chemical equation or chemical formula that we can use to calculate rate of chemical reaction is that the change in the amount of substance divided by time taken. change of the amount of substance divided by time taken, because when we're talking about concentration, we're also looking at the amount of something. So this one is an overall chemical formula that we can use, but it depends on what we have been given in the question. So for example, let us look at this question. Lithium react with the oxygen according to the reaction. So here it's based on what I was saying in the previous slide, that the formulas, you need to be flexible to check what you have been given and use the formula correctly. Because for example, if we are to use here, use this example, lithium react with oxygen according to the reaction below. So we have a chemical equation here where lithium is reacting with the oxygen to produce lithium oxide. After 2 minutes, 4 grams of lithium has been used up. Calculate the rate of reaction. Now, to answer this question properly, we need to find out what we have been given in the question and what we need to calculate what is required for us. So what we want to calculate is the rate of chemical reaction for this reaction. Lithium is reacting with oxygen to produce lithium oxide. Now, we can break this question into two. First of all, if we are to use the formula, we said rate of reaction refers to change in the amount of substance divided by time taken. So when in this case, the amount of substance that we can find, it will be number of moles because of the concept that we've been given in question. So here we can't use concentration because there is no any concentration given. So we are going to use number of moles since we have been given mass of lithium. So we will go back and look and calculate number of moles. That is number of moles of lithium. So the mass is given here as 4 grams, and we can use molar mass of lithium, that is 7 grams. So we're going to divide, and the number of moles is equal to 0.57 mole. The grams and grams cancelled, so the number of moles will be 0.57 moles. So that is the first step. So the first step is to calculate number of moles of lithium, since here we have been given the mass of lithium. Step number 2, we are supposed to convert time into seconds. We won't use the minutes, we'll convert the time in seconds. So if you check 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. What about 2? So it means 2 multiplied by 60, we're going to have 120 seconds. We have 120 seconds. On step number 3, we're supposed now to calculate rate of reaction using our formula that we discussed in the previous slide. So in the previous slide, we said rate of chemical reaction is equal to amount of substance divided by time taken. So in this case, a rate of reaction of lithium used is equal to moles of lithium used divided by time. So we found the number of moles of lithium to be 0.57 mole, and we're going to divide by time taken, that is 120 seconds. So the answer is 0.005 mole per second. So this is the hour rate of chemical reaction. Time taken for the reaction to get completed is this one. Now, we have talked much about the reactions. We have talked much about the definition of rate of chemical reaction. Now, we need to look at conditions which makes the reaction to take place. There are some conditions which makes the reaction to take place. So if those conditions are not available, it means a chemical reaction cannot take place. So for a reaction to take place, the following must occur. The first one, the reactants must collide. So if maybe, for example, you take a bottle of acid and put it somewhere else far, and you put a bottle of calcium carbonate somewhere else far, These things will not collide because they are separate. It means no any reaction can take place. So it means they need to have to be in contact for chemical reaction to take place. The second condition is that the particles must have enough activation energy. We have introduced another term, that is activation energy, where in the next slide we'll be able to define the term activation energy. So the particles which are reacting or colliding, they must have enough activation energy. If there is no enough activation energy, there will be no successful collisions. The last condition that must be there for a chemical reaction to take place is that the reactants must be aligned properly at a correct angle to collide and break in order to form new bonds. So they must be at a correct angle. What does this mean? It means that they must be aligned properly for them to collide. Otherwise, for example, if the other one is in a bottle and the other one is a container, that is not proper alignment. It means they cannot get in contact. So why chemical reaction occur fast or slow? For us to understand and answer these questions, we'll look much on factors that affect chemical reaction. These ones will be able to answer questions why some of the reaction are fast and other reaction are very slow. When we look at some of the factors that affect rate of chemical reaction, we'll be able to answer this question. So for us to understand and answer this question, we should consider theory that explain about the phenomenon. So the theory that we are supposed to understand is about collision theory. So collision theory, what does the collision theory says? Before we look into collision theory, we have talked much about energy. Where does this energy comes from? So according to kinetic theory of matter, matter is made up of smaller particles, which are known as atoms. So those atoms possess positive and negative subatomic particles, that is protons as well as electrons in their energy level and nucleus respectively. So since they have oppositely charged subatomic particles, this one developed kinetic as well as potential energy. When we look at potential energy, it's the stored energy in a particle or a substance, while kinetic energy is the energy of movement. So now back to what we want to look at, the theory. According to the theory, chemical reaction occur only when there is proper orientation of reactants, sufficient energy in the reacting reactants, and successful or effective or fruitful collision of reacting particles. That is according to collision theory. So for collision theory, we have said that for a reaction to occur, these three things must be there: proper orientation of reacting reactants, sufficient energy in the reacting reactants, and successful or effective collisions between reacting reactants. If they are not there, it means a reaction will not take place. In summary, for a chemical reaction to occur, the reacting particle must collide at a precise correct angle and must have minimum amount of energy for the bonds to be broken and for the bonds to be made. So as I said in the previous slide, I said that we are talking much about energy, that the particle must have minimum energy. What is activation energy? So activation energy, the minimum amount of energy needed for collision to be successful. Energy that is needed for a collision to be successful. Now, we should be able to put this one in mind. Note that all collisions that happen between the reacting particle are successful. It is only successful collisions which lead to a chemical reaction, while other collisions can be unsuccessful due to limited amount of energy in the reacting reactants. This may affect the reaction and the reaction cannot take place if the collision is unsuccessful. So first we need to look at the reactions which are involving solids. So the reaction involving solids take place at the surface of the solid. In short, if you have a solid particle, it means we have some small particles outside that particular solid, while other particles are locked inside that solid. So the reaction will only take place between the particles which are found outside the solid and the other reagent, while the particles which are found inside, they can only take part when they are in contact with the reagent. So for the collision, it means the only particles which are found outside are the ones which are going to collide with the reagent. So in solid lamp, most of the particles are locked inside. In order to react, the particles must have fruitful collisions with the reacting agent. So here what we mean is that in any solid substance or a reaction where one of the reactant is solid, it means only the particles which are found on the outside the surface are the ones which are going to be in contact with the reacting reagent, while those which are inside, they can only come in contact when the first one which are outside are used up. So if the reacting reagent is liquid or gas, their particles collide with particles of the solid. So here it means when you are reacting a solid and you are reacting a solid with a reagent which is either a liquid or gas, it means it is going, those liquids or gas, they are only going to react with the particles which are found outside the solid substance. So in gas or liquid, the particles are constantly in motion. During reaction, the particles collide with another. Factors, now let us look at the factors that affect rate of chemical reaction. So when we look at these factors, we are also going to answer the question which we stipulated in one of the previous slide, where we say why chemical reaction is either fast or slow. So these factors, when we'll be looking into each and every factor, we'll be able to answer the question why some of the reaction they are slower and the other are fast. In short, the factors which affect chemical reaction alters the rate at which the chemical reaction occur. So there are several factors that affect the rate of chemical reaction. Some of them include surface area of the reacting substance. If a reactant is a solid, we look at the surface area. Concentration of the reacting reactants when the reactants are in aqueous state. Use of a catalyst. Temperature at which the reaction is taking place. Pressure of the reacting reactants if the reactants are in gaseous state. Light intensity as well as nature of reactants. So these factors may alter rate or speed of the chemical reaction. The effect of any above mentioned factor determined, they can be determined in the lab by doing the experiment. Now we'll start looking at the first factor that affect rate of chemical reaction. That is the effect of surface area on solid reactant. So as we already said that solids, if they are reacting with a reagent which is either in liquid or gaseous state, it is only the particles which are found outside that particular solid, the ones which are going to be engaged in chemical reaction. The reason is that the other particles are locked inside, so they do not have any chance to have in contact with the other contact with the reagent. Remember, we said for a chemical reaction to occur, one of the conditions is that we need to have successful collision between the reacting reactants. So if something is locked inside, there will be no any successful collision between the particle and the reagent. So the relationship between the total surface area of a given solid and the number of particles, there is a relationship between the total surface area of a given solid and the number of particles. So we're going to look at the relationship now. So for example, if you have a solid cube made of 8 smaller wooden cubes bonded together using a cell tape, we can calculate the surface area. Then split it into single cuboid of 1 centimeter by 1 centimeter and calculate its surface area collectively. Now, if we split it, we'll be able to check which one offers large surface area. So we can have a diagram here. This is what we are saying. This is a large particle, solid particle, where smaller cuboid are locked inside. Here, can smaller particles which are bonded together with a cell tape, and those small particles can even be uh, even made smaller, as you can see here. So later on, let's check on what is going to happen. So first of all, if we have if you have one large um, solid particle, if we check on the total surface area, this one has 24 square meter, while this one has 24 centimeters squared, and if we split it into two, it is going to form 32 square centimeters, and if we split it into four, it is going to form 40 square centimeters. So if we are to compare the surface area, you might see that if you have a large solid particle, the surface area is small. Why the surface area is small? It means other particles are locked inside. As you try to break it, other particles are going to be exposed and the surface area now increases. So from the above example, we will state that as the number of particles of solid increases, the total surface area becomes large. In chemical reaction where one of the reactants is solid and the other one is liquid or solution state, the reaction can only take place on the surface of the solids. Since the surface area of the solids depend on number of particles of the solids, this means that the rate of reaction is affected by the number of particles of the solid reactant. What do we mean when we are saying this one? Well, it means that if you have a solid substance, other particles are locked inside. So rate of chemical reaction is affected by the number of particles which are exposed and which come in contact with the reacting reagent. So when you break that particular solid particles, it means now you are increasing number of those solid particles since others were locked inside. Therefore, if the number of particles increases, it means rate of reaction increases. Why? It means there will be more collisions between the particles and the reacting reagents, unlike when you have large solid particle where the reaction will only take place between the outside particles and the reagent. So here we are summarizing everything that I've spoken. We're saying that therefore as the particle solid gets smaller, the surface area increases. This increases the contact between the solid and the reagent. Hence, there will be more surface for collisions to occur, making them to have more successful collisions per second and increase rate of chemical reaction. Just maybe to have a recap, we are saying that if you have one large solid particle, other particles are locked inside. So it means that reaction, it will be only between the particles of solid which are found outside that block and the reagent. But if you break that solid into smaller particles, it means now you have increased the surface area. How? You have many number of particles after you have broken it. So it means many particles are going to be colliding with the reacting reagent. So there will be more successful collisions. Therefore, the reaction rate increases. So in summary of what we have spoken on how surface area affects rate of reaction, we can say that when the surface area of reactants is increased, more of the particles are exposed. This is true. This one we can take it by looking at the large surface area. You can take it by the large solid block and the broken solid blocks. So when the surface area increases, there will be more particles. When you block the large solid particles, there will be more particles of the other reactor which can react with the other reactants. For example, if you have solid reactant grinded, into a powder which increase the surface area. This means that more of the reactant particles are available now. They can interact with the reacting reagent. With large surface area, the number of collisions between reactant particles increases. As we break the solid particles, we are going to have many solid particles now, and there will be more particles which are colliding react with the reacting reagent. This increases the number of collisions. This is because the reacting particles are spread out more, allowing them to come in contact with each other more frequently. Due to increase in number of collisions happening, the rate of chemical reaction generally increases. This is based now on the theory, collision theory, which states that the reaction to occur, reactant particles must collide with a sufficient energy and proper orientation between the reacting reactants. So everything what we have said on how rate of reaction affect chemical reaction is based on the collision theory. Now, just to sum up on how rate of chemical reaction affect how surface area affect the rate of chemical reaction. We are saying that when the surface area is increased, there will be more contact between reacting particles. This will increase the number of collisions, successful collisions. Hence, the rate of chemical reaction increases. When we increase the surface area, there will be many particles which will be exposed and collide with the reagent. Hence, there will be more successful collisions. This will increase the rate of chemical reaction. Unlike when the surface area is small. When the surface area is small, it means some of the particles are locked inside and they are not going to be in contact with the reagent. Therefore, there will be few number of successive collisions, hence the reaction rate decreases. So this is what we have discussed on the factor on how surface area affects rate of chemical reaction. Now we have a buzz session, a quick exercise where we need to check our understanding on what we have covered based on the success criteria that was eluded in the first slide. So we are supposed to define the following terms as used in chemistry: chemical reaction, rate of reaction, activation energy. Explain why particles sometimes collide and products are not formed. Explain why one has to strike a matchstick for it to ignite. Explain why there will be no reaction between solid sodium chloride and solid lead nitrate. And you have another question, that is question number 5. Sodium react with oxygen according to the reaction. This is our chemical equation. After 5 minutes, 20 grams of sodium has been used. Calculate the rate of chemical reaction. This marks the end of the presentation. And before I go, if you have any question, you can find us through the WhatsApp number which is here, or you can visit xulendo.org. For references, we can refer to gather more information in the following resources. We have Excel and Succeed Chemistry Book 4, Achievers Chemistry Book 4, Target Chemistry Book 4, Django Chemistry Book 4. So for the photos that we have used here, the following are the links where you can click and learn more about our lesson. But this marks the end of our lesson.